This video is the digital version of the Properties of Ionic, Polar, and Non-Polar Covalent Compounds lab. We will be performing 5 different tests on samples such as paraffin wax and sugar to discern their simple physical characteristics. The goal here is to classify these as ionic, polar, or non-polar covalent based on their electronegativity differences. But really to answer the question, can we determine bond type based on properties? For instance, are all non-polar covalent compounds hard? Or do all polar covalent compounds melt? I'll be running through these tests one by one for 6 different samples, and I'll guide you through the results every step of the way. For the first test, I will be performing a hardness test. However, before I do so, I would recommend that you classify these materials as either ionic, polar covalent, or non-polar covalent based on their elements and their electronegativities. So for instance, this first sample is paraffin wax. You can see that it is composed of carbon and hydrogen alone. You might want to pause the video now to determine whether this is ionic, polar covalent, or non-polar covalent. However, for the hardness test, I will simply take a piece of this paraffin wax and smush it between my fingers. Your goal is to say whether this is hard or soft. I will tell you, based on my classification, that as I try to squish this between my fingers, it does not deform. It is an exceptionally hard piece of wax. So paraffin wax, I would classify as hard. For our second sample, that being Crisco, Crisco is composed also of carbon and hydrogen alone. Go ahead and classify this as ionic, polar covalent, or non-polar covalent. For the hardness test, if I take a small sample of Crisco here from the side and I squish it between my fingers, I can see that Crisco is exceptionally soft. It squishes between fingers very, very easily. So Crisco is soft. For the next sample, we are going to use sugar. First thing to clean off the Crisco. So sugar, the chemical formula, contains carbon, hydrogen, and oxygen. Remember, for compounds with multiple elements, more than 2, choose the highest electronegativity and the lowest electronegativity when determining bond type. Go ahead and determine bond type now. I will also take a small sample of this sugar and rub it between my fingers. I can see some of its coating based on the Crisco that's still there, but what isn't coating the gloves is hard and crystalline and gritty. So the sugar I would consider as hard. Now for the next sample, we have cornstarch. Cornstarch actually has the same chemical formula as sugar, or a similar chemical formula to sugar. It is composed of carbon, hydrogen, and oxygen. Go ahead and classify the bond type for cornstarch now. And I will perform a hardness test on cornstarch. Cornstarch is a very soft powder. It rubs between the fingers very easily. It is exceptionally soft. So I would classify cornstarch as soft. Up next, we have calcium chloride. Calcium chloride, you'll see, is these small white pellets. And the chemical formula for calcium chloride is CaCl2. Calcium chloride has both calcium and chlorine in it. Go ahead and classify the bond type now. And for the hardness test, I'll rub a bit of calcium chloride between my fingers. And calcium chloride, these pellets are exceptionally hard. You can't really squish them. They're like small little crystals between my fingers. Calcium chloride, very, very hard. And now for the last sample, we have sodium acetate. Sodium acetate has many chemicals inside, many elements. It has sodium, Na, carbon, hydrogen, and oxygen. Remember when determining bond type to take the highest and lowest electronegativities in your calculations. Now for the hardness test, I'll rub a little bit of this between my fingers. And just like cornstarch, maybe a little bit less so, this sodium acetate is a very soft powder. Not gritty at all, very fine, soft powder. So sodium acetate is soft. And that is it for the hardness test. Now, the next test is the smell test, a very silly test to watch someone else do. I will run the same samples in the same order, and I'll also call them out before I do so. What you'd like to record is either smells or does not smell. We'll start with the paraffin wax. Paraffin wax by itself doesn't really have much of a smell. It has a very, very, very faint smell, sort of like a neutral oil, kind of, but it's incredibly faint. I would record smells, but honestly, it's not much, if anything. The Crisco coming up second. Crisco has a much more pronounced scent, even though it's not incredibly strong by any means. There is a scent with Crisco. It reminds me of baking because I bake with Crisco sometimes. So Crisco definitely has a scent, sort of like a cooking oil. Up next, we have sugar. So sugar's a weird one. You might expect to have a scent because you have tasted sugar, but does it actually have a scent? I'm going to get some a little bit closer to my nose from this beaker, but I'll still waft. I don't smell anything from sugar. Some students have told me they do. I personally don't smell anything. I would say no smell for sugar. Next, we have cornstarch. Cornstarch. There is a very faint smell for cornstarch. Hard to describe. I would describe it as starchy. It's kind of like if you ever smelled flour, for instance. It does have a very faint smell to it. So cornstarch does have a scent. Next, we have calcium chloride. Calcium chloride, these little pellets right here, also sometimes used as road salt. I smell nothing for the calcium chloride. So no smell for calcium chloride. And finally, we have sodium acetate. Sodium acetate, I would say likewise, no smell for sodium acetate. And that is the smell test. Now for this next test, we're going to be melting our samples, or seeing if they melt within 1 minute. I will arrange the samples across this hot pad here, and I'll label them in the video as to what they are. But from the top left corner, they will follow the same pattern, going in this order. We'll start with paraffin wax. I'm going to put these on for 1 minute, and we'll see if they melt. So the paraffin wax is on, the Crisco is on, the sugar is on, cornstarch is on, the calcium chloride is now on, and the sodium acetate is now on. So let's see if they melt. You can kind of already see that some samples have indeed melted. So I can see that this paraffin wax over here, this has already pretty much melted. It still has a little bit to go there at the edge. I'm just going to take this off. We can successfully say that paraffin wax does indeed melt very easily. Same thing with the Crisco. The Crisco is very obviously melted here. Next, we have in the back, you can see this sugar is starting to melt. You can actually see it's starting to caramelize here in the center. I'm going to take the sugar off before it burns. It has indeed melted. Now, our last three samples, the cornstarch, the sodium acetate, and the calcium chloride. I don't see any change, and we're just getting towards that 1 minute mark. I'll zoom in on them here. Calcium chloride, I don't see anything going on with calcium chloride. I don't see anything going on with sodium acetate, and I don't see anything going on with cornstarch. So those three do not melt. Our next test is the solubility test. For this test, we're going to see, does our sample dissolve in water? I will pour this distilled water, just a little bit, on top of each of our 6 samples, and then I will pause the video and show you what the results are after swirling these for a minute. So over the paraffin wax, over the Crisco, I'm just dumping about 20 milliliters or so of distilled water. And we'll come back to these results in about 1 minute or so to see if these actually dissolved with a little bit of manual swirling. And now I have my results after a minute of swirling. We can see the paraffin wax did not dissolve. There's still a huge chunk of it there at the bottom. It did effectively nothing. Paraffin wax, we'd say, is insoluble. Does not dissolve. The Crisco, likewise. Crisco, the old lump there on the bottom, Crisco did nothing. It did not dissolve. It is insoluble. Next up, we have our sugar. Now, our sugar did dissolve. You can see the solution is clear. There's no sugar there at the bottom. Let's see if I can get it on screen there without spilling it. No sugar left. It's dissolved in that water. We'd say that sugar is soluble. Now, cornstarch is a little odd. Cornstarch disappeared, but it turned the solution cloudy. This technically did not dissolve. It just got dispersed throughout the liquid. So cornstarch, even though it's not still the powder that we saw, it is insoluble. Didn't technically dissolve. It would have to be clear for it to dissolve. The calcium chloride, though, those small white pellets, they are gone. They, in fact, did dissolve. Calcium chloride, absolutely dissolved. Very clear. It is soluble. And finally, the sodium acetate, likewise dissolved. No sodium acetate powder left. All turned clear in the solution and dissolved. Sodium acetate is soluble. Now we'll move on to our very last test. Now for our last test, we're going to test conductivity. We're actually going to use our results from the solubility test to see, is it conductive? If it is, this light bulb will light up, and if it's not conductive, it won't. And actually, we'll have 3 levels of results here. We'll say no if the sample is not conductive, low if the sample has low conductivity, or high if the sample is highly conductive and makes this light bulb glow very bright. We'll start with the paraffin wax. So the paraffin wax, I will put between these leads. I can see that the light bulb did not go off, so this has no conductivity. We can write no for this sample. After each sample, I will wipe down the leads to get any residue off, and also rinse them with distilled water to make sure that the next sample isn't contaminated. Now the next sample is Crisco. Let's see if Crisco is conductive. Crisco is not conductive. That light did not go off. Once again, prep this for the next sample. And now our next sample is going to be sugar. Let's see if sugar is conductive. So sugar is also not conductive, not at all. Sugar does not conduct electricity when dissolved in water. So far, not the most interesting test. So that's 3 out of 6 samples not doing anything with conductivity. Going in the same order, we now have our cornstarch solution. Cornstarch, likewise, not conductive. Not make the light bulb light up at all. Now for our final 2 samples, we'll start with calcium chloride. Calcium chloride, once dissolved in water, indeed lights up the light bulb. Now this is exceptionally bright. I don't know if you can tell on your screen. This has a high conductivity. And our very last sample, our sodium acetate. This has a low conductivity. It's not quite as bright as the last one. It's kind of on the edge. You could honestly say low or high. It's definitely conductive. For this one, I'm going to go ahead and say high conductivity. It's a little bit lower than the calcium chloride, but still conductive. So that sodium acetate had high conductivity. Now, that is all 5 tests for all 6 samples. Go ahead and make sure to record these results and answer the conclusion questions on the front of your lab packet.